Hi everyone, Mr. Barden here. Today I'm going to be talking about how to use the circuit diagrams that we'll be needing to do for the physical computing unit in the Programming Digital Media course. You may notice that unlike some of my more recent videos, this one is currently being live streamed in one take. It's just that time of the year where I don't have the time to go in and do all of the editing for all of my videos every week. I'll start being able to do that again as soon as all of my papers are due. So moving on from that, I have here this website. This is going to be the website that I'm recommending to use for creating these circuit diagrams that will be part of the assignments that we have to turn in. There are other things out there for sure. This one is free though, so that's why I'm recommending that you use it, because it's free and it's online. If you wanted to use a paid one, there's an app called Fritzing that you can get. If I where did that go? I'll just show that just so that way it's there. I have a link in the description. It's loading, but basically both of these programs can be used in order to generate diagrams of the circuits that you have to build in the course. And it's going to be part of the assignments that, along with whatever codes you have to turn in, that you turn in this diagram. You can, as well as, pictures of what you're taking, what you're making. So that way we can go in and be like, okay, this works, this doesn't. Yes, you made the thing. Here's how it all goes. Because again, you only have your one little Arduino kit, and you got to make one thing, turn it all in, make another, and there we go. And the program here, Fritzing, is still loading. So once that loads, I will show that off. I'll take a little pause from where we are. But what I've got on the screen right now is this website called TinkerCAD.com. It's free. You can log in. I know I can make classes with it and set it all up. But I think for how I'm going to be using it this year, we can just make the assignments, take the screenshots, and we'll be good to go. We'll kind of play it from there. All right, and Fritzing has just loaded up. So I'm just pulling this over here. This is a paid option, so I'm not requiring anyone to get it. But basically, you can make schematics here on the breadboard. You can set up the kind of wireframe schematics that you'll see in the textbook. You can make the various, as if it was a circuit board, and write code that would then be applied to it so that these would be animated to look like what they would do. We don't need to get into that, but again, you can very easily stick the various components that you need, put them wherever you want, change them up, and we'll get into that as we go. And check out my videos on just making Arduino stuff and how that's set up in order to check that out. But again, I'm not going to require that you use that, and these programs work pretty similarly. So I'm going to highly recommend checking out the free one. You can log into this. If you're one of my students this year, you can just use your student email that you normally use. But again, it's free. You can log in, make an account, and eventually you'll get to this point up here with your kind of dashboard of everything. And I want to point you to where it says circuits, and that'll take you to this screen. And what I'm going to start with is just going through the kind of tutorials they have for getting started. So if you hit the Try Circuits button, it will load. And we get pulled up with this screen. So there's some instructions on the side here. There's the circuit that you will have built, and then the components you can use to build that circuit. So we're going to be learning how to make that. So I'm just going to walk through some of this tutorial. So we're going to test this circuit right here. We hit Next, and we're going to simulate what our circuit does. So once you've built a circuit, you can simulate what it is. In this case, all this one does is power a LED light. You'll notice that it turned on. I'm going to hit stop, and it got darker there. That part's pretty easy. Hitting the next bit, and that's, again, just simulating the first circuit. There's a few pre-made examples that really won't be relevant here, but we'll go on. We're going to go into the next thing now. Just know that once you've built it, you can simulate what they would do. Next one, editing the components. This is where that panel over here on this side of the screen is going to be important. So again, we can stick an Arduino board, and again, this is a replica of the one that we will be using in the course as I teach it. So you'll be able to match everything up perfectly fine, but we can diagram the circuits that we're going to be building. So let's get started next. All right, so you'll find that there are 3 LEDs, 3 resistors, and an Arduino. Don't worry about that for now, it says. We're going to say click on the topmost LED, and you'll see an inspector appears that lets you edit the properties of the component. So again, you can change the name, and this one it wants us to change the color of it to red. So I'm going to set that to red. The middle LED, we're going to do the same thing, set it to yellow. And the bottom one to green. Green. Notice how it's matching up with the colors of the wires here. So you can set the colors of your wires to be various things. You're almost always going to want power here from the circuit to start with to be red, and then the to ground to be black. Sometimes you'll see green, but black and red, power, ground, that's going to kind of be the standard. Everything is connected up here. They're all lined up. You can adjust some of the wire color, the wire types, and the wire color over here in the menu. I'm sure we'll get into that, but we've now adjusted the LED colors. And let's move on to the next thing. Test your circuit. We're going to start the simulation. Oh, that's just the image. I thought that would link. We're going to click that. So you notice it now looks like it's plugged in. And we can see that right now the LEDs are blinking in order. There's some code involved in this to get this up and going just right. We can check the code tab to see what that would look like. But again, I'm going to have a whole separate video on making code in Arduino, so you can check that out, or if you want to learn more about it yourself. This has similar concepts to what the course has been doing so far in JavaScript, but some of the formatting is a little bit different just because it's built out of C and not out of Java. So again, I'll hide that and I'll stop the simulation. You notice I kind of like this. It plugs it in versus unplugging it. Because again, to get all the power for this, by default, the Arduino is getting it from the computer, run the code. You could also plug it into other power, but we don't need to get into that too much. All right. You can change the color of your wires. Again, that's the drop-down menu. What happens when you edit... Okay, what happens to the brightness of the LED when you edit the resistor it's attached to? So this is something that's kind of important. If we click on the resistor and we have the resistance here, let's make that 100 ohms. We'll make this one 500, and we'll make this one 10. You'll notice that you can set the resistance of each resistor manually, and then the bands change to represent that correctly. If we start the simulation, you'll notice that the brightness of these LEDs, they're no longer all the same. This green one is really, it's kind of bright. This red one is very bright, comparatively speaking. Actually, what did that say? That gives you information on the current and stuff like that. All right, and so now we're going to go into how to make all of this. But just notice that, like my introduction thing, as the resistance changes, the current changes, and that'll determine how bright your LEDs can get. Excuse me. Okay, let's move on to the next one. We're going to be wiring up the components. It's got to load. Okay, so again, this is a breadboard, and we're going to be learning how to wire everything up so that way it works properly. So the positive side of the battery, we have the battery here, and we're going to be connecting positive. If you hover over it, it says it, or it's the red one, and we want to connect it to the positive line of the breadboard here. All right, we got that there. Click. There we go. Got to click and then click again to drop it. Negative, same thing. You want to negative, drop it there. If you wanted to, you could drop it down here as long as it's on that negative kind of row. Everything will line up. You'll notice that, again, like all breadboards, the one side does not link up to the other, but they've gone ahead and in this example set up these jumper cables to patch that up, so everything, both sides will line up. All right, what we have going on here, it looks like we're going to be wiring up these resistors and triggering it with these buttons here, getting it all connected, and that will adjust things to set up. I think this is a speaker. Yeah, it's a little speaker. It's okay. So we've set that up. We're gonna hit next. We wired up the negative side of the battery already. Okay. Start the simulation. Now that we've powered it, we're gonna test that. So click the Start Simulation button. It's starting to make sound now. You may or may not be hearing it. But now there's 8 buttons, so we can click the buttons and hear different things. And you may or may not be hearing that. I'm not intentionally capturing the computer sound. But the way this one is set up, you'll notice that each of these resistors is different. All right, so we got the positive signal that's going through here, positive, and then it's connecting to the various elements in order to power the speaker. The buttons are then being used to kind of trigger certain amounts of that. So again, the different buttons with the different resistors are changing the amount of electricity, changing the sound coming out of the speaker. So a super high note versus a super low note, and something in the middle. Okay. Try, and then we hit continue to the next step. Congratulations, we've learned how to add wires and power a piano circuit. Again, it's pretty simple. You'll notice that each of these elements has a terminal. All right, so if I hover over it, terminal 1, terminal 2, 2, 1, again, is kind of signal going in, signal coming out. So you could click on that in order to connect a wire to it. So let's say we wanted to connect terminal to or something to this row here. Again, just how breadboards are set up, we could connect that there. We can click and how does this want to go? This one doesn't like me. We'll use this as another example. I'll pull up a resistor. We can stick it somewhere, and that is kind of the default there. These are kind of chained all right together, but we can set up wires by... Oh, yeah, you right-click or control-click to do the wires. So you again, I right-clicked, and let's say I wanted to connect that to here, this row. I just drop, or I let go and I click there again, and it drops it. I can highlight it and change the color. So now it's an orange wire. So again, you can set up your components. I'm just selecting and hitting backspace to delete. So you can find your various components, drop them onto the breadboard, connect all the wires up, and there we go. Lesson completed. All right, adding components. This is probably going to do what I just told you how to do. To make an interactive motor controller. Basically, we're just adding a switch or a variable potentiometer, a variable resistor or potentiometer to this circuit without having actually gone through this before. It's my first time looking at it, but if I had to guess. All right, click the Start Simulation, and you'll see the motor run. Now it's running, and it's rather than animating it, it's just telling you how fast the motor is running. Kind of useful. All right, some instructions. Click the plus components and search for a photoresistor. This is already open, so let's say photoresistor. There we are. So now we can let's see. Click and add it to the circuit below. So I'm going to click and drag, and there we go. We can select it and hit R to rotate it. So that way it just faces correctly. so that the pins are facing up. There we go. Pins are facing up. It then wants us to delete this red one. And then we're going to connect it from there to there. And from there to the other terminal right there. There we are. All right. There's also a trash icon up here. You can delete something that way. Wireless. Continue to the next step once we're here. All right. Works by sensing light. Let's test how it works. So we're going to start simulation. Click on the photoresistor and we should see a slider appear. Okay, so I was slightly wrong with how this goes. I saw this slider and thought it would be an object. But now, so a photoresistor responds to light. Basically, there's some chemicals in here, and as the light hits it, that causes the resistance between this side, you can see the metal right here, and this side to change. So that way, as there's more light, more current can jump across that gap and power things up. So as we start increasing the amount of light, you'll notice that RPM start to turn up until we get as much as it'll do right there. And then we can just turn it back down to something a lot slower. Okay, next. Continue tinkering. And basically, at this point, that's all you really need to know. You can, again, in the little window here, pull up. Here's a lot of the more common ones. So if you had some motors, some batteries, if I wanted to stick a potentiometer here, we could add some resistors in as well, things like that, and that would, start to go that way. So if I went down, actually, I don't even know if this will work. I'm just kind of messing around. Yeah. It's exponential, but again, I'm missing some stuff to make that actually work properly and safely. But yeah, that's you can just add your stuff to it. So if we wanted to make a switch, let's see. I'm just flipping that over. Let's see. So I think we want. Oh, I didn't want to zoom in. I think, if I remember right, the switches kind of go like that. No, I think I've got that backwards. Stop simulation. So instead, we'll do it this way. We'll do it this way. There we go. So again, we can set up a switch, so now it's on and off, and on and off. But anyways, I'm just messing around at this point. Lesson completed, and we've gone through all of that. So again, that's just basically how to make up all of this stuff. So I'm going to go back to the main page here, circuits, and let's create a new circuit. It's loading. So for this one, we can, under the components, there's a variety here. Let's go to Arduino with a breadboard. We want that one. This will kind of be what we start with. Oh, I didn't want to. Okay, there we go. So we can set all that up. If we needed a bigger breadboard, I'm sure we could find that, or we could link up to other ones. Yeah, we could line up some big or small breadboards right here. But again, we have this set up here. Again, in this circuit, we're getting the power from the computer, so that's why it's hooked up right here. So again, I'm just going to walk through this kind of on my own, but we're going to just make an LED that powers on. So if I zoom in, come on. I did it once by mistake. There we go. So I'm clicking and dragging to zoom in, focusing on the breadboard right here. Let's go in and find an LED. There we are, LED. Just going to pick a basic one. I'm going to click and drop it right here. That's where I'm going to put it. Color. We didn't use orange last time. Let's use orange. All right. LED, so a resistor. We're going to need a resistor. We're going to need to come back. Change that up so that way they all line up. And then let's check the resistance because we don't want... Come on. Can sometimes be a little picky. There we are. Resistance, let's go 220 ohms. So there, I get the... Actually, it's kind of backwards. It's kind of red, red, brown is how we would see that one. So I'll flip it that way so it actually reads red, red, brown. So we got that right there. So now we just need to connect all of this up. So if we, in this case, control click, go to the negative here, and then if I control click, drop it on the positive right there, I can then go in here, change it because that's positive. This is negative. It's just that way we can tell what's going on. So the way the electricity will run in this circuit is it's going to come from the computer. The positive power is going to come out of this pin, run to here, and it's going to run along and right there. So it's going to send it along. So anything connected to this horizontal row will receive the power. So that's where this connects here. So then anything to this row 23 is going to be getting power if we connect it there. So I've connected the resistor going into the LED. So again, everything here is now connected, which then connects to that one. And then goes down here to the negative, which then goes down to ground. So this should pop up and light up. Yay! So again, everything is up and going right there. So that is basically it. And this is actually going to be the first circuit that my students make, is just wiring up an LED. You get that 220 ohm resistor. They can pick what color it is. It's a little hard to see in this diagram. If we pull out an LED, you'll notice that one is straight, one of the little terminals, and the other one kind of pivots out. On the physical LEDs, one side is longer than the other, one little wire. The reason for that is that electricity can only flow one way through the LED. If I rotated this around so that it was backwards, it wouldn't work. So again, the longer leg, terminal, wire, whatever you want to call it, that's where you connect to the positive end. And we can actually, I don't actually even need this. Delete. That would be the positive end. You know, so when we're coming from the positive, connects to that longer cable, and then this one goes to the negative, to ground. So that's why we could have that there. If you wanted to wire up a switch to control this is kind of where I'll end things off today. Switch. All right, let's use this switch. So let's see, we can connect that one to there. I'm going to move this resistor over here. Set it up this way. to... I'm just trying to make everything line up well. All right, well, you know what? We'll do it... Yeah, stop it. I keep zooming without meaning to. We'll do it this way with jumper cables. All right. So again, our resistor. So we're going to go from the resistor to our switch. And I'm actually going to make this yellow. I'll make all these yellow so we can tell them apart. And the switch, we're going to go from the switch to the row, the positive right here. And then we're just going to connect that negative end up. So what this should be doing, start simulation. There we are. So again, if you wanted to be super safe, you could even connect this one right here. Control click, control click. Come on. Oh, I got to stop the simulation. Control click and send that one to ground. You don't necessarily have to, but just know that the way this switch is going to work, if I can zoom in, there we are, is that it's going to take this power, from this pin, and it's going to send it to either the middle or the third pin. So so right now it's sending the power to the third pin. It's just completing the ground loop. Everything is transition there. So if you connected anything to this row, the switch would switch between the two. So that if I start simulation, I switch it and it's on and it's off. On, off. Like that. So look at that. So if I wanted to stick another LED, here, like that, and then just jump it over there. We should, we're going to find out if I forgot the other resistor. I think this will work because we only have one light on at a time. But we have this light, and that's not working. That's okay. Stop simulation. So can I just option click to... No, I can't. All right. Fine, I just wanted to wrap this up with an easy example. That's not what I wanted to do. Why? Why are you doing this? I didn't even want to... What is this? Resistor here. You are going to, by default... Come on. It's not always the most user-friendly thing. Resistor, I want you at 220 ohms. We're just going to connect you from there to there. Yeah. That can go away. That can go away. Huh. Why is the red one not working? No, they're both not working. Okay, fine. I'll do it this way. Stop simulation. If this doesn't work, I'm going to stop. And because again, I didn't plan any of this. Connect you there. Connect you to there. Connect you to here. No. Connect you to there. And now it's getting angry at me because it's not being resisted before. Oh. That's why that one's angry at me. Didn't update the ground Didn't update the ground cable. I mean, maybe that's part of it. Connect that to there. Connect this to there. That should all be going. Why does this red one not want to work? Am I misunderstanding how they program these switches? It just switches where the power gets sent to. All right, if it doesn't work at this point, 'cause it should, just take it, send it out here, and then send it out there, and then they both are going to ground. So it's boom, 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 ground, boom, 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 boom. I'm not 100% sure why that one's not working. But, oh well, we get the point. Again, that was just me trying to make something off the cuff, but that should, in fact, be working. I don't know why, but we're going to end it right there. So, again, by watching this and watching me struggle for a little bit, you should have an idea of how you can go in and drop in components, connect them, simulate what's going on, and go from there. What I want to see if we can do to end this, if we go to export, that's not even one. I wanted just a photo. Share. There we are. You go to share a snapshot of your design. You click the download button, and boom, it will download a PNG of our design. And if I open it up, we get this. So my students, whenever you make a circuit, you're going to need to plan it out and turn this in as part of the assignment. Again, the whole point of that is, maybe something isn't working and I can look at your plan and see what's going on. You can, plan it out from start to finish. So that way you have a template to go for. We can pull this up and make it again after the fact. So for all that, and I can just see that you understand where the power is coming from and where it's going. So again, if you just export this, or it's the share button right here, and turn that into the Google Classroom, that'll be a good part of what we need. You'll also be turning in any code and stuff like that. And if absolutely needed, you can also just turn in a picture of your breadboard with all the components right there. So anyways, that's going to be it for me. I know I already said that, but now it's actually true. So I will see you all the next time.